So for this Atwood machine that is consisting of mass 1 and mass 2 around this pulley system, the Lagrangian L is T minus U, kinetic energy minus potential energy. So let us check their positions. So if here is X, from here to around this semicircle is pi r. Since the perimeter of a circle is 2 pi r, so half of it is pi r. So from here down to here is L. So that means that here is L minus X plus pi r. That means that here the velocity will be X dot, while the velocity here will be minus X dot. For the system, we can now say the KE of M1 and M2 is equivalent to half M1 X dot squared plus half M2 minus X dot squared, half M1 plus M2 X dot squared. The PE is equivalent to, so if we take the datum, the reference point, for M1 it will be minus M1 GX, and for M2 it will be M2 G into L minus X minus pi, so that you have it to be minus M1 minus M2 GX minus M2 GL plus M2 G pi r. You have that the Lagrangian is equal to, and you know that P of X is equal to the partial of the Lagrangian by partial of velocity. So you have it to be M1 plus M2 X dot. That's if we differentiate this with respect to velocity. And this implies that X dot is equal to the Hamiltonian H is equal to, and that's equal to P of X, our Q is equal to S in this case. So X dot minus this minus M2GL plus M2G pi r. Wherever we see X, we put this into this equation. We have Px times Px over M1 plus M2 minus M1 plus M2 over 2 Px squared over M1 plus M2 squared minus plus Q dot, that is our X dot, is equal to the H over the Px, and Px is equal to minus the H over the X. So before we do this, let us simplify this equation. So you know that this one will cancel 1 and it will remain this. Here is already Px squared over this. So we have Px squared over M1 plus M2 minus Px squared over 2M1 over that. So you have that H is equal to them minus this once. This implies that X dot is equal to, if you differentiate this with respect to Px, you have it to be 2 px over 2 m1 plus m2, and that is, let's call it equation 1. Also, p dot x is equal to this negative of that minus m1 minus m2 g. These ones are constant, so they 0, equal to plus m1 minus m2 g. Let's call it equation 2. From equation 1, this one, if we differentiate the velocity, we will get acceleration. That's x dot dot will be equal to p of x dot over m1 plus m2. If we now take this one and put here, you have m1 plus m2 x dot dot. That's if we make subject here, you have this. It's equal to m1 minus m2 g. So that if we make our acceleration subject formula, that's the equation of the motion, we'll have that m1 minus m2 over m1 plus m2 times g. So in other words, it is the x squared, the squared x over the t squared minus m1 minus m2 over m1 plus m2 g is equal to 0.